Hello ladies and gentlemen, today I'm going to demonstrate to you how to use this piece of equipment. This is called a logic trainer. There are a lot of buttons over here which you do not need to bother because we will not be using so many functions. Over here you see this is the breadboard which consists of a lot of holes. I'll explain them to you later. For the lab on the logic trainer, you'll be given some IC chip like this one. This is shown on the lab sheet for lab 6. This is the layout of this chip called the 74LS00. Alright, the 74LS00 consists of 4 NAND gates, as you can see over here. Now I'm going to show you how to put the chip onto the breadboard. Now you notice that for the IC chip there is a portion here. There is this part. This notch or this depression here which is at the top. So make sure that this one is pointing upward. Alright, otherwise you may mix up the position of the pins. This is the 14-pin IC chip, 7 pin on one side and the other 7 pins on the other side. Right? How do you put it onto the breadboard? Now you notice that there are a number of reaches here. So you want to put the chip in this way, okay, crossing the reach. You can put it here, or you can put it here, or here, or even here, or here, or here, or here. Alright, you don't put it here. The reason is that for the breadboard over here, you see a lot of holes, right? So the 6 holes that you see horizontally here, this set of 6 holes, they belong to one group, right? So every set of 6 holes is one group over here. Over here, you see this long black line. This means that this 4 sets of 6 holes, altogether 24 holes, they belong to one group. They are all connected underneath the board. Alright, for the shorter red line, it means that this group of 12 holes, they are connected. So the same thing over here, the red line indicates that the 12 holes are connected. The black line indicates that the 24 holes are connected. Right, so all the groupings are horizontal for most part of the breadboard except the bottom part here. And in the bottom part here, this set of 6 holes, they are connected vertically. So that's different from the top part of the breadboard. So you put the chip right crossing the ridge so that one side of the pins, okay, are not connected with the other side of the pin. If you do it this way, then the pin here and the pin here share the same group, which is wrong. Okay, so before you put in the chip, make sure that the logic trainer, the power is off, okay, and also make sure that again this notch, this notch over here is pointing upward, and the pins are straight and not bent. And then make sure they're aligned, and just check that the pins are aligned with the holes on both sides of the ridge, and then position them such that they are aligned. Okay, and once you have checked carefully that they are indeed aligned, then you press down firmly with both your thumbs until you hear the click sound. Alright, now this is very secure. You can't take it out with your hand or fingers, and you better don't take it out with your hand or fingers, because if you were forced to take it out, you may bend or may even break the pin. Okay, the right way to take it out, I'll show you, is to use this thing called the IC extractor. So you go underneath and then you pull it out slowly. This is the right way to take out the chip. Alright, don't use your finger. So let me put it in again to make sure that the pins are all aligned properly. Alright, all aligned properly. Okay, once you're sure they're aligned, then you press down firmly with both your thumbs until you hear the sound. Yes, right, this is secure. Now for every IC chip, okay, you will have a special pin called the ground, which is pin 7 over here, you can see, and the other one is pin 14, which is VCC of +5V. Okay, for every chip you have the ground, you have the VCC, and you need to connect them. Okay, so how do you connect them? For the ground, I will use the standard color code. I will use the black wire. I'll connect it one end of the black wire to the ground. There's a few ground outlets here, you can see. I will take one of these. Okay, for the other end, I will connect it to pin number 7, this pin number 7 is meant for ground. So pin number 7 is over here. This is pin number 7. It is connected to this group, so I can connect this wire to any one of the remaining 5 holes. Okay, so I can connect this to any one of the 5 holes. Okay, this connecting this to pin number 7. The next thing I will do is to connect pin number 14, which is 5 volt. Yes, I'll use the standard color scheme, red for the plus 5 volt. Alright, I'll look for the plus 5 volt outlet. There are a few over here and over here, so I just choose one of them. Okay, and as before, the other end of the wire, I connect it to pin number 14, which is the top right pin. So I connect it to any one of these 5 holes. Alright, there you are. Okay, so for every chip, you need to connect the ground and the VCC. Okay, if you need to have more than one chip in the future lab, suppose you have another chip, to make sure you don't connect it this way, because otherwise this side of the pin of this chip will be sharing the same group as this side of the pin for this chip, which is not right. So you can either put this further away or put it on the left over here, or put it above or below. Okay, now let's carry on. I'm going to demonstrate to you how to use one of the 4 NAND gates over here. The 4 NAND gates in this chip. All right, I'm going to use this one, the top left one. So this NAND gate has 3 pins. The first 2, 1 and 2, they are the inputs, and the third one is the output. So how do I connect up the inputs and the output? So for the input, I'll choose a different color. All right, this is the orange wire. So I will connect this to pin number 1. So for the input, okay, I will connect it to pin number 1 as before. I will put it into one of the 5 holes here, and then for the other end, I will connect it with one of these 8 switches here. Okay, right. On second thought, I think orange is not a very nice color, because orange is not good. We hope for yellow, and best, green. Maybe I change to green. It's much better, right? Hopefully everything goes well, and then we are back to green, huh? So I will use green instead. Okay, so connected to pin number 1. The other end, connect to one of the 8 switches. I choose this switch, so I connect to this switch. Okay, this switch will allow me to choose between 0 or 1 later on. So the same thing for pin number 2, which is the other input for the NAND gate. I'll connect it to pin number 2 over here. Okay, the other end, I will connect it to another switch, this one. Okay, so these are the 2 inputs. For the output, I choose a different color, blue. Connect to pin number 3. Pin number 3 here. And where does the other end go to? I can connect it to the LED display. There are 8 LED displays here. I will choose one of them. Okay, let me choose the leftmost. There you are. I think I'm done. Okay, so once you've connected everything, what you do now is to turn on the power. Okay, currently you see that this light is on because it's a 1. Why is it a 1? Because the 2 inputs is set to 0. So this is a NAND gate, so when both inputs are 0, the output is 1. If I turn the input to a 1, 0, the output is still 1. If it's 0, 1, the output is still 1. Now if I turn both inputs to 1, the output will be 0, so there's no light. Okay, so this is a very simple demonstration on how to use a single NAND gate. When you come for the lab, the lab TA will go over this demonstration again. After that, you can try it on your own. You can try out with a circuit like this using 2 NAND gates. Okay, so yes, once you're done, you can turn off, and then you can take out the wires. But do take out the wires carefully. Don't pull them out. All right, and remember, don't take out the chip with your fingers. You need to use the chip extractor. Okay, there's one more piece of equipment I need to introduce. This is called the logic probe. Okay, this is an equipment that allows you to check the circuit, right? It's like a debugger, right? So you find that the circuit is not working, you wonder why, then you can use this piece of equipment, logic probe. So let me set it up. There are two crocodile clips here, one black, one red. So the black is supposed to be grounded, the red is supposed to be connected to the plus 5 volt. So let me use the red wire, okay, for the plus 5 volt. Okay, and then another wire, the black one, for the ground. Okay, so the red crocodile clip onto the plus 5 volt, and the black crocodile clip onto the ground. Okay, so we can now turn on the power. Now you see there are two switches over here on this logic probe. Okay, this one is TTL and CMOS. We'll choose TTL. Okay, we use TTL chips instead of CMOS chip. For the bottom is memory, PAL. We are not using any memory function, so we set the PAL. So TTL, PAL. Alright, so before we use the probe, let's check whether it is working. Okay, so what I can do is this is the tip of the logic probe over here. I can bring the tip to maybe a ground, and you can see that the green light is on. The green light indicating that it's low or it's 0. So ground is equivalent to 0. If I put the tip to the plus 5 volt, you see the red light. The red light means it's a high or a 1. Okay, so I can test it out. For example, you want to check, okay, what happens at pin number 1. So I can touch pin number 1. It's red because currently pin number 1 is connected to this switch, and this switch is set to high, or 1. If I turn the switch, okay, if I turn the switch to low or 0, then the logic probe change the color to green, which is 0. This is how you use the logic probe. Okay, yes, that's about it. So come for your lab 6. Your lab TA will go over this demonstration for you, and then after that you can try it on your own. And subsequent lab 7 and lab 8 is supposed to connect up the circuits and stuff. Alright, so yeah, have fun. Thank you.